some points, and then
Gotta make sure it's recording from the right channel.
it'll
Always forget
change
about
the
that.
output again. Like
Doing it round.
and it gives you the opportunity to redo it. But if you notice you did something bad and you go back and try to redo it, it rewinds the entire story to there, so you have to work your way back up. Yeah, like just on the campaign.
Okay, so let's go ahead and get started. We are getting back onto Cengage, so for those of you who have access to Cengage, excuse me, food and drink. Yep. You can hold off a little bit, right? You're not going to faint on me. Okay. I know how it's like, got to do things in the morning, don't have time to eat breakfast. Okay, so we're getting back to information systems analysis and design, which is kind of a really I would say kind of dry and boring topic. But sometimes if you look at this, you can look at it from a different perspective, like what is an information system? They only talk about the business type or organizational information systems, but sometimes you can also think about information systems as in the ECU, the engine control unit of a high performance car. That is an information system as well. It's just that it's very different, okay? But if you look at it from that perspective, things are a little bit more interesting. We went kind of really slow last time. I think we talked about transaction processing system. I'll let you guys read the rest of section A. It talks about management information system, MIS, decision support system. Those two are basically, very related to transaction processing systems, except, you're getting different types of information out of the system. So instead of just recording and logging transactions, you are, in the case of MIS, you are trying to extract information for management. Okay, you're trying to get reports, monthly, weekly reports for management. For instance, you might be managing a team of salespeople, so you might get a weekly report of, who sold how much, whether it's an increase from last week or decrease from last week. What is the year-to-date, sales amount and stuff like that. So that's MIS. DSS or Decision Support System. I'm just pointing here. Refers to specific programs that will try to project the future so that you can make better decisions. That's a little bit more involved because it also involves modeling. In other words, you kind of have to think about, okay, if we set the price of this product to this much, okay, how would that impact the sales of the product? The profit margin per sale, per unit may lower, but at the same time, because it may sell more, the actual total revenue may actually bump up, and you also get a better market share at the same time. But that involves a lot of modeling because you need to kind of model how the market is going to react to a price change on your part and how your competitors will respond to that. So that's that's definitely more than just getting information from a database, because you're also using a mathematical model to decide, okay, to determine what the future may be depending on how you want to change certain things. The last one is expert systems and neural networks. That by itself is one upper level class at a 4-year university. Okay, it's about AI, artificial intelligence stuff. Basically, an expert system is a system where you can just ask it questions. Now we have all done that already. If anyone has tried to fix a car using one of those good old paper-based manual, it has an expert system in it already, because at the back of the book it starts with questions, right? Can you start the car? Yes, go to this page. No, go to the other page, right? If you cannot start the car, you get to that page, then it will ask you, does it even crank? Do you hear a click? Okay, nothing. Go here. If you hear the engine cranking, like wow, 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 it just won't start, go to this page. That's an expert system. Except in this case it's on paper instead of being interactive. All right? But you can kind of imagine how expert systems can be useful in many different types of organizations, like Kaiser Permanente. Okay, it's a health, it's an HMO. health maintenance organization. Is that what the M is? Health maintenance.
I think so.
Let's assume it is.
Yeah, sounds reasonable.
Yeah.
Okay, so you can imagine, with Kaiser, they don't want to put, all the doctors and all the, the RNs, on the phone, just so that they can answer your phone call, like, okay, I feel, I have a sore throat, I don't know what's going on, I need advice. Okay, so they don't want to put, high-paying employees on the line to answer those phone calls. So a lot of times they put lower, lesser paid employees, but they are in front of a computer. In other words, they are just reading the questions from the computer, and depending on the answer from the patient or the customer, they put in the answer into the system, and then the system will prompt the next question, the next question, and the next question. Now, if it does get to a potential problem that is serious, then only at that time the front end person will say, okay, I need to forward you to an RN or a doctor who's on duty. But for the most part, if it is not something that is serious, and the system indicates there's a remedy or there's a solution, there's a way to treat it, they would just kind of read out the instructions, and that's an expert system. All right. Are there any questions about expert systems, in general? It's a fairly easy chapter to read. Section, in this case, section A is fairly easy. So we'll just kind of go ahead and start with section B, and we'll see whether we can finish section B and C today. So we're going to move a little bit faster today. There we go. All right. So this is systems analysis, which is something that we have talked about already. And here's a summary of the life cycle. It's actually not a cycle, because this part here, this arrow, is not, supposed to be there. They call it life cycle because it's better than calling it just the life the life of an information system.
The lifeline.
Sorry?
The lifeline.
The lifeline, exactly. Segment. Chain. All right, so it starts with the planning phase of a system. Now this link here is from the previous system. In other words, at the end of the lifespan of the previous information system, it will lead to the planning phase of the next information system, the next full information system implementation. So we'll talk about the planning phase, the analysis phase, the design phase. We may or may not be able to get to the implementation phase today. But we talked about this stuff already using the analogy of building a house. Do you guys still remember? Kind of? Okay. So this is where you will sit down with an architect and you will say, I got this much money, I want the house to be built by this time, I have these requirements, I want the house to be really secure, so crooks cannot easily get into the house, da-da-da-da-da. So that's basically in the planning phase. The analysis phase is your architect and your engineer working together, trying to make sure that they can actually get the house built or designed during that time. So I'm kind of rolling these two into one, analysis and design. And then the implementation would be your contractor actually building the house. Maintenance is you living in the house with gardeners and plumbers and electricians and stuff like that, people like that, to help maintain the house so it remains livable. And at a certain point, your house will become too old to maintain anymore. In other words, you have to put in a lot of money to keep it maintained and keep it in a good shape. So at that time, you can demolish the house and start with the next house. So that's basically the analogy that we used earlier, like on the Tuesday. The planning phase basically just describes how do we get started with a project. If you read this part, there's a lot of fuzziness about it. Okay, this entire chapter has a lot of fuzziness because systems analysis, in general, how do you get a system from its conceptual phase, like okay, I think we need a new information system. How do you get it all the way to oh, okay, now we have a new information system in place and it's working. Okay, we have people using it. How do you get from the first stage all the way to the last stage? It's very fuzzy. Okay, it depends on the organization, depends on the scale of the project, depends on what kind of people are on the team. Okay, And it also depends on many other aspects of a system. If you have something that has to be done within a certain time frame and there's no wiggle room, you have to do it in a certain way. On the other hand, if you just need to get something out the door and you have time to refine it later on, you can use some other models. Okay? So we'll go ahead and take a look at some of these things when it is time to kind of focus on it. I'm going to skip a lot of these things. There will be a lot of jargons, a lot of abbreviations like joint application design. It basically just says, okay, we need to bring the users into the whole team so that they can provide, feedback like, okay, the last system, prompted screens like that, and we did not like it because it takes like 20 clicks to get to what we need, and we want this system to be a little bit more efficient. So we want to bring the end users into the team to help provide more realistic feedback on a system that is still in the design phase. And that's basically what JAD is about. Because you don't want a whole team of programmers and systems analysts and only having those people to design the system, because it may be technically very superior, but if the user interface is inferior, nobody's going to like it, nobody wants to use it, and then you have a big problem at the end of the entire project, because when you roll out the system, nobody wants it. Then it becomes a very expensive system that is capable and yet ineffective at the same time. So we're going to move on. Why are new information systems developed? That's a really good question. It depends. In some organizations, especially when they have external consultants involved in the process, it's just because some people need to make money. There's no actual need for a new information system. It's just that some people say, oh, you know what, we can incorporate all these cool new features that are not necessary, into a system, and we'll give you a bill, send you a bill in the end. Okay, so we have that situation, but in most situations, it's because the old information system is too costly to update, maintain, and bring up to date anymore, and as a result, you need a new information system. Now, this can be the obsolescence of not only the software, but also the hardware. Can anyone kind of imagine why hardware obsolescence can lead to a new information system? What do I mean by old hardware versus new hardware?
Less capable to process or store information.
Okay, but what type of hardware are we talking about? When I say some hardware is getting obsoleted. Because if you think about it, in terms of PCs, the new PCs, with a i7 core, quad core, hexa-core, or whatever, they can still run DOS, right? I mean, if you have DOS, the original floppy disks of DOS, and want to run an emulator, it can still run DOS, all the programs that you used to run in DOS. So there's no such thing as obsolescence in this case, because you can renew the hardware and just bring the old software to work in a new platform. So what am I talking about when I talk about hardware obsolescence? Mainframes. We're talking about mainframes, IBM, mid-end mainframes, and also the 360 system. There are a lot of hardware. They used to be, mainframes and very capable. People write all sorts of programs on those systems, but they are getting obsoleted. Okay. When something is obsoleted, what does it mean? Think about a big mainframe computer that takes up the entire room, like this room here, just for one installation. Okay, why would a system like that get obsoleted? Let's just say that the software is still capable enough, that it will still serve its purpose. The system is still fast enough to do what it is supposed to do. So let's not talk about performance or efficiency. What do you think can happen to a system that says, well, you know what, it's time to get rid of that system?
Size.
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 Size. Okay.
How big it is. Property is really expensive to maintain for computers. So keeping it smaller is less to maintain. So, or they can even add even more computers into one room.
Right. Okay, that's one reason. What other reasons?
Energy efficiency.
Energy efficiency, that's becoming more and more important. Yep.
Compatibility.
Compatibility with
With
new software.
I guess.
Okay. you guys are forgetting one thing. We're talking about hardware here. Something is going to break, right? Now, for instance, hard disk drives are definitely scheduled to die at a certain time. Okay, they cannot run forever. It's no big deal. All systems have hard drives, and all systems need to replace hard drives. The problem is the hard drives that these old information systems are using, they cannot be bought anymore. Nobody, for the past 20 years, no one has made a new hard drive for this particular mainframe anymore. So you will basically just use up everything that is in stock and stored in a warehouse somewhere else. And what if you have used up the last hard drive? And all the new hard drives do not have the necessary interface to plug into your mainframe. That's hardware obsolescence. You just run out of replacement and repair parts. Okay?
Could it also be that the cost of the old technology
Yep.
is greater than the cost of the new technology? Because this
Absolutely. It's just not cost effective anymore to maintain and repair old systems. Yep, that's definitely one of the reasons too. And this is why IBM kind of makes its name in the business world, because it will spend a lot of resources to keep its old systems up and running. As long as the customers are still paying for the service, they will fly around to collect parts, to keep one system up and running. All right. So that's one very important reason why new information systems are developed. Other reasons can be changes of software tools. Okay, I cannot get into a whole lot of details here, but in the old days, before relational databases, we had DBase 3, okay, which is a database program, but its function is very limited in terms of what it can do compared to relational databases that we have today. So that's why if you have an old information system, based on DB3 or DBase 3. You will find that your information system is no longer competitive. Your competitors have better stuff, and they can outcompete you. And that's one reason why some corporations will want to have a new information system. Are there any questions at this point? Now it says right here it might not be the current system can be manual. So in the example that we used on Tuesday, the library. Okay, 20, 30 years ago, all libraries, rely on paper cards as their quote-unquote information system. But these days, it's not cost-effective anymore. You can still do it, definitely, you can still do it that way. It's just not cost-effective because libraries, especially public libraries, they're running out of funding. Okay, the state is not, giving them as much money as before. They cannot hire as many people as before, and for the most part, they don't have as many books as before. Because people are shifting to ebooks and other types of publications, but still they need to streamline how they spend the money. And an information system, even though it can be expensive for the first few years, down the line it can be inexpensive. And then it talks about threats and opportunities that can affect an organization. That really has to do with external forces. That impacts the decision of a particular organization, trying to reinvent or get a new information system. And then it talks about how an information system can help an organization to respond to threats and organization and opportunities, improvements, change the industry, and create new products. Now, make improvements is kind of a given. Okay, why would you get a new information system if it is not improving anything? Changing the industry, that's interesting. That is an interesting one because we are seeing new industries or industries shifting in directions that we have never seen before, almost on a daily basis. Okay, can someone give me an example of a kind of traditional industry but is kind of moving in a different direction now because of technology?
Regular towers, they're getting shifted to little towers now.
Mm-hmm.
And it's constantly getting smaller and smaller.
And at a certain point, it will change how people use the computers. Right, go ahead.
Apple computers, they started out with just personal computers, and then they branched out to tablets and smartphones.
Mm-hmm. And before iPad, became, popular, when we use tablets, we are talking about PC tablets, and they still require the use of a stylus, because the operating system, which is usually Windows, still requires a pointing device and a way to click something. Now, because the iPad, decided to use a touch interface instead of a stylus, it reinvented the front end. Okay, so that it only requires touching and also gesture, and that really changed the industry, because now when we talk about tablets, nobody thinks about would think about a stylus or a little pen anymore. Everything is now just finger touch based. And create new products. New products in this case would be products that are based on the internet or information system. I can give you one really funny example, and don't ask me why I know that one. Pork rinds, okay, pork skin, the deep fried pork skin. There's one company, so I think it's in the one of the southern states. So there's a company who's really famous for making that kind of product. It's now marketing directly on the internet to people. In other words, it's not being sold through stores. It is now having its own website and say, okay, you can order. And it allows people to order like cases, like big quantities of that product. Okay, so we are talking about a really old-fashioned industry, okay, deep frying pork skin. I mean, how old-fashioned can it get? Okay, and yet the company saw the possibility to market it directly through the internet, and it can reach customers actually much better than selling through Walmart and many other organizations. They don't have to deal with the middleman at all. They do have to deal with FedEx and UPS and stuff like that, but since it's not explosive or anything that's dangerous, I can hardly imagine they can get into any type of problem with FedEx or UPS. Yeah, pork rinds has a lot of energy, but not explosive energy.
They do some.
Even the spicy ones. Yes.
I've seen microwavable ones.
Oh.
Microwave, it comes out same way.
It's like popcorn, right?
Yeah, exactly. In the same type of container. It was interesting.
So that's a shift of that's a shift of direction of how businesses conduct business because of technology. All right, so now we have even more jargons, okay? A new information system may be only one aspect of a larger plan to evolve an organization into a stronger, more competitive entity. And these are components of a business that can make use of information technology more so than other aspects of a business. The first one is BI, business intelligence. And don't ask me why they come up with these abbreviations when the term itself is perfectly fine, but they want to kind of make abbreviations out of it. And the abbreviation doesn't even spell a word. It's not an acronym. It is just an abbreviation. Does everybody know the difference? What is the difference between an acronym and an abbreviation?
An acronym actually spells out a word or something like that.
Yep.
Like what?
Like,
Wine is not an emulator.
Yeah.
yep.
Laser.
Laser is an acronym because it's pronounceable. Okay, it's actually pronounceable. There are actual words too, like GNU, GNU. It's an animal. Okay, but it also stands for GNU is not Unix. Okay, and those are acronyms, and that's why they can be. You can just say GNU instead of GNU. But these are not. I mean, if you look at these, most of these are not pronounceable at all. And yet, people just use these abbreviations. Business intelligence, an integrated set of technologies and procedures used to collect and analyze data pertaining to sales, production, and other internal operations of a business in order to make better business decisions. Okay. So we just talked about MIS and also DSS earlier, decision support system. And those are all components of business intelligence. Okay, you might also have tools to kind of browse through websites of your competitors and look for updates on a daily basis. Those are automated tools, and it's legal. Okay, as long as your competitor does not mark their website as not crawlable by a search engine, you can design your own tools to crawl through a competitor's website to look for updates, new products and new ideas and stuff like that. Okay. The next one is business process reengineering. This has to do with reworking the procedures used by a business in order to make it more efficient and more effective. CRM is a big one. Customer relationship management is a big thing, because a lot of times businesses do not just want to sell you one thing. They want you to come back and buy some more. Okay? So CRM is all about that. It's basically how do you maintain a good relationship with a customer. Now when people talk about CRM, a lot of times they're not talking about individual customers like us. They're talking about corporate level or government level customers, because those are big accounts. Okay? If you lose a big account like a certain branch or a certain department of a government, you're losing a lot of money to your competitor. If you're losing one end user, one customer like Amazon customer, you know what? It's not a big deal to Amazon. So CRM is particularly important to large organization customers. So you can kind of imagine that Microsoft, and Microsoft vendors, people who sell Microsoft products, emphasize CRM a lot, especially in Sacramento, because we have the state government here. So they have specific companies who specialize in CRM, with the government, within the government. We have EIA, Enterprise Application Integration. It's the use of network-compatible software modules, and a good example would be Microsoft Office. It's an application, but it can also work at an enterprise level. What do I mean by enterprise level? I mean, Microsoft Office is Microsoft Office, right? Microsoft Word is basically a typewriter on a computer. So what is enterprise? What is the enterprise portion of it? Any suggestions? Shareable, okay? You have SharePoint, okay? Microsoft products can hook up to SharePoint. So, but why do we need SharePoint or something like that? I mean, I just shotgun my email to all everyone who needs a copy of the Word document, and when they're done editing, I would take it all back in, and I look at the highlight, I would incorporate the changes, right? But that's not very effective. So the most effective way is to open up your document for revisions. Okay? And when people make revisions, they will only be, you can highlight all the changes, and then you can say, I want to accept this change, reject that change, accept this change, reject that change, and so on. And you can also integrate from multiple people, not just one. So you can shotgun the document to 20 or 30 people, and collect the input or the revisions from all those people, and incorporate the changes back into the original document without having to print anything out and do a visual compare. So that's enterprise level integration, or one aspect of enterprise level integration. Unfortunately, people move very slowly. So even though Microsoft Office is capable of revision control and stuff like that, there are still many people who refuse to use it. Many people still want to print everything out and work on the hard copies. Yep.
I know someone who works for a large insurance company, and they use SharePoint, and instead of her area uses SharePoint, but then the other areas don't use SharePoint, so they actually have to download the document, make changes, then re-upload that version of the document, and then it has to come back to her.
That's a nightmare to maintain, the changes, because it's just much more difficult when it's not inside the document itself. Then you are responsible to actually compare and say, okay, this part is changed. You have to integrate it into the actual original document. EDI, electronic data interchange, and that's what Exchange can be useful for. It's not just email, but how do you transfer data between different companies using networks like the internet, and also buy, sell, and trade information. Okay. ERP, resource planning. We actually do that here at ARC and the Lost Reals Community College District too. It's basically just talking about what kind of resources, especially with money, properties, and so on and so forth, and how do you manage all your resources? How do you plan your resources, and how do you use your resources? just in time, is a buzzword these days. Okay, it's particularly because Java has just in time compilation, and I think that really pushed that term up to the front end, and people want to use the just in time term for everything now. It's basically just in this case is manufacturing system that are fully integrated with an information system. So instead of getting, okay, we just make this thing one way, you get it and you modify it yourself, you can actually put in the order and say, okay, I want this to be specialized like this. And because of the information system, it can put things into the box in a different way, depending on what you want. Think Legos, okay? Think about Legos. You go to Walmart, you go to Toys R Us, you go to the Lego section, what do you see? You see boxes, right? And can you control what pieces go into the boxes? No, absolutely not, okay? And if you try to do that at the store, you get kicked out of the store, right? I like this piece better, so I'll just kind of put this piece in here, but I'll be fair and I'll put some other pieces into the other box, right? They won't let you do it. But you can kind of imagine, if Lego opens up a web interface that actually let you customize, how you want to order your Legos. So you want 20 of these pieces, 4 of those pieces, and 5 of those pieces. That would be kind of cool.
Why wouldn't you just order it from the Lego store then?
Yeah, but Lego store, does it let you, put together packages like that?
Yeah. If you call it into the store and tell them to ship it to you,
Okay.
they will pick it out for you.
But can you do it through the web interface?
I'm not sure. I don't order it from them.
Because my kids go to that interface all the time, and I have not found the actual custom order. You can order certain packs. I think like specialized packs for motors and gears and stuff like that. Yep.
They also have a program where it's basically like 3D simulated Legos that you can build stuff in it, and then you also have the option to order all the pieces that it has, and it'll come with like an instruction booklet.
Yep. So that would definitely fall into the JIT, just in time, type of technology. Then we have MRP, manufacturing, instead of enterprise, manufacturing resource planning. Now this is a big deal for any type of business that actually produce any parts. I used to work in a company in Davis that produced embedded systems, okay, single board computers, and this is a big deal because you have to plan. If your end product requires, let's say, components A, B, C, D, and E, okay? A, B, C, D, E are the components. The question now is, how much do you buy ahead of time? If you don't buy enough, then you'll run out of parts on your shelves, and then you have to wait for parts to come in. You cannot fill your own orders, and your customers will be unhappy. And plus, if you order only like 5 or 10 at a time, a lot of times it costs you a lot more. Instead of when you order like 100 at a time, you get a much better price point. On the other hand, if you order thousands at a time and you can only sell let's say 200 in a year, what do you do with the other 800? You pay for that already. Okay, it's money that you have already used. Instead of you cannot use that money for anything else. So you don't want to order too many. You don't want to order too little. So the question is, how much do you order? And the next question is, do you want the system to automatically reorder for you when the stock level drops to a certain point? Okay? Because that can be very helpful. Instead of having someone to say, oh, we just ran out of component A, need to reorder. You have to wait for 2 days for the order to ship and get delivered. And if they run out of stock at the distributor, then you have to wait even longer, right? So having a system to automatically monitor not only your stock level, but also the stock level with the distributor, so that you can say, oh, the distributor is running low on this part, even though we are not running low yet, it might be a good idea to order some more now, just in case the distributor runs out soon. Because with semiconductor, the thing is, when something runs out, when a chip runs out, it can run out for the next few months. And that's because the plants that manufacture chips, they will do batches, right? They will run batches through. So it depends on if you run out of let's say component A. The next time the manufacturer runs another batch of component A can be months away, because they may have other products that can make more money, that are more popular with more demand. So the one part that you need which is not really popular, only you and a few other people need, they would just kind of postpone that and go like, yeah, we'll make that in a few months, because right now our pipe is full with stuff that will actually make us a lot of money. So you have to take all of that stuff into consideration when it comes to manufacturing resource planning. Pork rind is a little bit easier to manage. You just need what? Oil and pork skin and spices and stuff like that. So it's a little bit easier to manage in that case, huh?
In a bag to hold it.
Yep, bags. And the last one is TQM, which is also a very big buzzword. Anyone who wants to go into business and stuff like that, especially with management, really need to look into TQM. It's a technique initiated by top management that involves all employees and all departments. It focuses on quality assurance in every product and service offered to customers. So when you call up customer service and they say, okay, we may need to record a conversation and stuff like that, it's a part of the TQM. Okay, it's one link of the TQM approach, because they want to have ways to monitor and also look and evaluate what is the quality of service in this case. And all of these can make use of information systems. What do you think an information system can offer to TQM? Total quality management, just quality management, if you will. I'll give you one scenario. Okay, I'll call up T-Mobile and just tell them, you know what, I called you guys up the other day, and somebody promised me that I can get this upgrade for free for 2 years, and how come it's appearing on my bill now? I'm not happy. Okay, it's a quality issue. Okay, the quality of your service sucks. Okay, so how can a computer help in that case?
Documentation.
Recording the conversation, okay, recording everything, all the deals, who, made what promise, everything has to be written up. So the information system can say, well, you didn't really place a call, to order that, service on that day, and so on and so forth. Or, we can replay the conversation. Okay, we told you that there will be a surcharge of blah 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 blah, and you said it is okay. You understood, and you said it's okay. So you cannot come back and say that it's our problem that we did not tell you about the surcharge. Okay, so that's that's one aspect of it. You can also look at it from the perspective of making some stuff. Pork rind. How can pork rind TQM make use of an information system?
I want a new flavor.
But that's not quality. That's a new service, right? New product. What about quality control?
Something wrong with the product.
Something wrong with the product. You can actually collect statistics, information. You can have someone who's sampling the output, looking at the bags, looking at the pork rind, see whether it's too small, too big, too hard, too soft, and so on and so forth. And you can collect statistics. Okay, so you can say, well, out of this month, 10% of our product really cannot be shipped, and then you can try to find out why it has changed from last month, which may be only 5%. So the information system can help you collect and also help you analyze the information collected by people, so that you can ensure that the quality is better next month. Okay, how does the project team identify problems and opportunities? So we see these terms again. We have seen it before, and seeing these terms again. We have performance. Yep.
Sorry, off topic. Have you passed around the roll sheet?
No, I have not. Thank you. Oh, by the way, I found an app to turn off my ringer at certain times. So it's really helpful. That's why I don't see it. Huh?
That's convenient.
Yep. And it's free. It's a free app. This is cisc310. I think it's just called Silence Scheduler or something like that. If you just look up the words, silence and schedule, you will find it. It just works, really well. It turns off the ringer, at certain times you can pre-schedule. It's based on days too, so it's based on days and time. So it's not just daily, you can just say Tuesday, Thursday during this time, Monday, Wednesday during this time, and so on. All right. So we have pieces again. The first, so these are potential problems. Okay, this time we look at these words as potential problems of an either existing information system or something that we should be aware of. One is performance. Okay, now what is the difference between performance and efficiency? They seem to be related, but they are not exactly the same thing. Think about cars. Think about cars. Okay, you can have a car with superior performance, but not much efficiency. Okay, think Ferrari and Lamborghinis, right? Yep.
Performance would probably be more linked to things being at a date, whereas efficiency would be more linked to.
How do you measure? How do you measure performance? You can measure performance by number of transactions per second, speed, right? You know, how many things can you do per second, per hour, you know, and so on. That would be a good
Efficiency
measurement.
is the number of resources it requires to do that.
Exactly, in terms of money, in terms of energy, in terms of physical size. Okay, so that's efficiency. I drive a car that has kind of I wouldn't say top rated, but pretty good efficiency, but no performance whatsoever. It's worse. It's a Honda Civic Hybrid 2005. It has a 1.3 liter engine. Yes, some lawn mowers probably have bigger engines.
I had a go-kart as a kid that had. I think I had a go-kart as a kid that had a bigger.
But it has an electric motor, so it has really good efficiency. It's really good on gas, and also the price point is good because Civics are not, the resale value is not as good as Prius, so I didn't have to pay nearly as much money as a Prius of the same condition of the same year. But it doesn't have performance, right? Just about any car can beat me, off the line. Even a cyclist can easily beat me. Oh, cyclists are really fast, because there's not much dead weight. So from 0 to 15, a cyclist can be really fast. After 15 miles per hour is a different story. Huh?
Can't really do highway.
Nope, cannot do highway. So P is performance, and this second E is efficiency. Okay. Information, an existing information system may not be collecting all the information that needs to be collected or providing all the information that needs to be provided to the users. Economics means the system costs too much to operate or use, and that is not the same as efficiency here, because the efficiency here has to do with the technical efficiency, not the money-wise efficiency. So the money efficiency is they just put another E to it, so we can remember the word as pieces instead of PICES, which is not a word. Control, a system, in this case control is related to security. Who gets access to what type of information? That's what the C is for. So it's remote, it's related to privacy, it's also related to security. The last one is surface. A surface problem means the system is too difficult or inconvenient to use, which means it can fit all the other requirements, it's just not easy to use. Now that part depends on whether the user group has a tolerance of systems that are difficult to use. In some cases, if the system is open to external customers, typically if your surface is poor, it's not good because users can shift to a competitor product. If it's an internal system, then you just get complaints. you just get people saying, how come I have to click 20 times to get to this screen? And it can impact organizational efficiency as a result. So these are things that the system needs to look into when you are in the planning phase. A system development methodology. Now that is a very interesting topic that deserves its own 3-unit course easily. It's basically a question of how do you want to develop a new system? I mean, what do you mean by how to develop a new system? I mean, it's all those phases that we talked about. We survey the land, we design, we use an architect, we use an engineer to make sure everything is good. We go through a few iterations, come up with a blueprint that is both feasible, we can do it, and to the satisfaction of the customer, and then we build it. we inspect it, we test it, everything is good, we move in, we maintain the house, the best we can, and that's the end of the story. What do you mean by different methods of doing it? Well, when we're building a house or something that's physical or big, we only can go with those rigid type of methodology. When you're talking about an information system, there are different ways of doing it. One is called RAD, which stands for Rapid Application Development, which means you're not producing the final product the first time. You're creating the system in steps. Okay, so you're creating a system to get it done in a very short amount of time, but it's very limited. It can only offer certain types of services. It's not complete. As time goes on, you add more features. You change the system as as people start to use the system. They say, oh, this is not really good. Well, we need this feature, and so on and so forth. So there's a model called RAD, Rapid Application Development. The conventional way of doing things is actually called a waterfall method because it's step, 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 step. So it's called a waterfall methodology. In this case, their structured methodology is the waterfall, and then we have object-oriented methodology, which is kind of beyond the scope of this class. You really have to take CISP 400, which is object-oriented programming, to really understand what it means when people say object-oriented. We got a little bit of that taste of object orientation when we use Scratch to do something, because Scratch is quote-unquote object-oriented, or I should say sprite-oriented. Okay, because when you write a script, you are always thinking and writing the script from the perspective of a particular sprite. In other words, if you have two sprites and you want to move them in different directions, and when they collide, you do something else, you're not saying sprite 1 do this, sprite 2 do this, and so on and so forth. Sprite 1 has its own script, sprite 2 has its own script. Okay, so it's those scripts, you're looking at things from the perspective of a sprite, not from the overall system. And that's sprite oriented. And object oriented is similar to that concept.
Would flowcharting be object oriented?
No, flowcharts is definitely not. Yeah. Flowchart is definitely process oriented or logic oriented. You're looking at the logic of how it's procedural. You're looking at the procedure, one step, one step, one step. At this point, I have to make a decision. If this condition is true, we go this way. If the condition is false, we go that way, and so on. So it's definitely procedural in its nature. All right. So now we talk about project scheduling, which is very exciting. Not really exciting. It's not exciting, but it is something that is important. Okay. We have program evaluation and review technique, which is a method of analyzing the time needed to complete each project task, and so on and so forth. Certain things you can make very good predictions about how long it will take. Okay, how long will it take to produce 200 pounds of pork rind? Right? That's
pork rind.
Yeah, well, I'm kind of hungry too. So
Yeah.
Okay, how about sushi? Okay, how much time will it take to produce 50 rolls of a certain type of sushi? That, after doing a few times, you get a pretty good hang and get a really good estimate of how much time it will take. Why is it kind of predictable, given the ingredients are all there?
Because there's no variation in what you're doing.
There's no variation.
No new variables to
Is there any problem solving involved in the process?
It's just a straightforward process.
It's a straightforward process, exactly. It's just one step followed by another step followed by another step. Now, in terms of quality, you do have some concerns like, can you make the sushi rolls exactly the same way consistently every single time? Okay, so that's a consistency problem. But in terms of how much time it takes to produce, one sushi roll, it's actually fairly predictable. What about systems development? What about programming? It is unpredictable. Okay, it's very unpredictable. It's because sometimes a tiny little problem may take 2 weeks to solve the problem, And sometimes a difficult problem, if you use Google and somebody else has already solved the problem already, it might take you 2 minutes to solve the bigger problem. So it's not even about the size or the nature of the problem. It has to do with, sometimes it's just lucky. Are you lucky and are you unlucky? Okay. You guys have any questions? No? Okay. Now, there was one time, since I wrote a lot of software, back in my other job, there were 2 instructions. This is assembly language programming. I'm not going to teach it here, but I just want to show you. One instruction is called in0. The other instruction is called in. Okay, those are the 2 different instructions. They take the same type of stuff, on the right-hand side. Okay. And when I wrote the program, I'm not sure whether it was me or somebody else. It was somebody else. I can blame it on somebody else, but it's okay. It doesn't matter who did it, right? Instead of using in0, which is the correct word to the instruction to use, that person used in instead of in0. These 2 instructions are closely related, by the way. They're closely related, with in0 being the more predictable one. This one depends on something else. Okay, so if something else is not 0, this will do something that's different from in0. But if that something else has a value of 0, in will do exactly the same thing as in0. Those are the worst kind of problems because it's not breaking consistently. Okay, the program was only breaking or it stops working occasionally, and this took me a week to find, even though it's only one single character in this case. It took me a whole week to find it because there's not a whole lot of tools to help me find this problem either. Okay, so that really goes back to program evaluation and review technique, because sometimes you can try to estimate how much time it will take to do a certain part of a project. You always have to think, what if it needs more time? You got to think, what if it needs more time? Do you have a plan B? Is there something else that other people can do when one person spends more time on this part of the project? Okay, so that's always something that you have to think about. And this is work breakdown structure. It's breaking up a big task into smaller tasks. Why do we want to do that? Breaking a long, big process into smaller chunks, smaller components. Why do we want to do something like that? Because people have ADD or ADHD. Well, that's what they say. If people have ADD, attention deficit disorder, or ADHD, it really helps to break things into smaller chunks. Or if people have anxiety, it also helps to break things into smaller chunks, so they can focus on the smaller part and say, okay, I can get this done in an hour, instead of looking at a big chunk and go like, oh, this will take me 2 weeks. Oh, I cannot get started. I have a headache just thinking about it. Okay, but instead, if you focus on something that you can do in an hour or half an hour, it's okay, right? I mean, you get it done, you move on to the next one. That will take another half hour or an hour. Then you move on to the next one. That will take half an hour to an hour. So in a day, you can get 8 little chunks done, instead of spending all 8 hours worrying and say, oh, I cannot possibly get this done. I cannot get started, right? Well, that's one reason. But the second reason is this will give you a better way to estimate how much time a task will take by breaking it up into smaller chunks, and then do a more accurate estimate of each smaller chunk. Now, the Gantt chart is extremely useful. I'm not sure how many people have used a Gantt chart before. This is a breakdown chart. It's just breaking it down, so you can use FreeMind or something like that to break it down. You don't have to display it like this. This is a Gantt chart. A Gantt chart is basically a timeline, but it's also separated into tasks. So you have tasks, going like this, and you have time going like this. Task A, in this case, will start, task B. So the completion of task A is required for task B to get started. And then task C, I don't see any dependency. And then we have planned milestone and actual milestone. Planned milestone means, by this time I should get a milestone, which means, something that is deliverable and measurable. Okay, you can say, okay, we are definitely done with this part of the project. That's a milestone. Instead of saying, oh, I spent 20 hours on this part of the project, I should be this way through the project, because time is not a good measurement of completion. You need deliverables, like, okay, can the information system get this part done? Okay, importing data from the old system. Yes, it is done. It's a milestone. Okay. So if you're not familiar with a Gantt chart or project management software, I would say it's worth it to look into it. There are open source products that can do the same thing. You might find it useful even for your own projects. Okay, anything that is long term, big, and so on, this can help you manage your time. Any questions? So we are moving on to the analysis phase. The analysis phase will begin after the project selects a development methodology, draws the project development plan, and receives permission to proceed from management. So all the good stuff with paperwork. So the one thing you have to do is to study the current system. If there's one, there's always one. Okay, even if it's not computer-based, there's always an existing information system with an organization, unless the organization is a brand new one and there's nothing installed at the point. The studying the current system will at least give you a few ideas of, well, what do we need from the new system? Because the new system has to do at least as much as the old system. So that gives you a baseline of what you need. And also, particularly the weaknesses of an old system, because you want a new system to overcome at least some of the weaknesses. How does the project team discover what happens in the current system? Well, why would that be an issue? Because we have the end users, in the JAD, Joint Application Development, right? Well, unfortunately, that's not always the case, especially when the new system is going to be designed and implemented by a consulting firm. Okay, the consultants are external to the organization. They were not there to use the old system whatsoever. Okay, so that's why that's why this question is important. How does the project team discover what happens in the current system? Is they really have to kind of shadow someone who's using the existing system to try to figure out, okay, this is how the system is being used, these are the strengths of the existing system, these are the weaknesses of the existing system, and that process can take quite a bit of time. Think about Wells Fargo Bank. Okay, think about Wells Fargo Bank, and let's say that the management decides, okay, we need a new we need a new information system because the old one is not competitive anymore. Bank of America or Chase is beating us because they have a better system. Okay, so they bring in an external firm. Let's say they bring in an external firm. They don't have an internal organization to do it. So they bring in consultants. The consultants may know a lot about banking systems already. They may know a lot about financial institutions and whatnot. They have a lot of that knowledge. But they don't know exactly how the existing Wells Fargo system works. Okay, so how do they get that knowledge? Surveys. Okay, surveys is a quick way to do it. You just design the survey to ask certain questions, but that will only give you summarized information, opinions, and stuff like that. What about the daily operations? Okay, what kind of operation or what is the procedure of a teller? If someone is trying to withdraw money, what is that process? If someone is depositing money, what is the process? Well, one way is to shadow someone, right? Just kind of stay with someone, not being intrusive. Just to observe, how things are done. Do it for a few days, then you get a pretty good idea of how things are done using an existing system. These days, since we have camcorders and resources to do recordings, that can be helpful as well, because you can record it and then review it later, and you can just say, okay, I'm replaying this process here. See right here, the teller has to press this button and then press that button. I think that's not an efficient way of doing it. We can improve it by doing da 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 da. So having a video recording of an existing process or how an existing system is used can be helpful. How does the project team determine what the new system should do? Well, the project team includes people who have ownership of the new information system. So they should know the requirements, kind of not in a technical way, but in some other ways they know. Okay, we want this new system to be blah 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 blah. So it says right here, system requirements are criteria for successfully solving problems identified in an information system. These requirements guide the design and implementation of a new or updated information system. They also serve as an evaluation checklist at the end of the development project. So they're sometimes called success factors. A new or updated information system should meet requirements defined by the project team. The question is, how do they get these criteria to begin with? The project team determines requirements by interviewing users and studying successful information systems that solve problems similar to those in the current system. In other words, if you can get a consulting firm that redid the information system for Chase, you probably have a much better chance of improving your system to be at least as competitive as Chase's system, right? Another way to determine requirements is to construct a prototype as an experimental or trial version of an information system. Now that can be costly because you're basically saying, okay, make us, it's kind of like you're trying to design a ship, okay, to transport goods and whatnot. You're trying to build a miniature version of the ship and then bring it through like simulated storms and other types of factors and see how well the ship holds up against those elements. It can be very costly. That can be a very costly experiment. Especially when you find out the prototype does not work the way it's supposed to. So it explains right here, often the prototype is not a fully functional system because it's designed to demonstrate only selected features that might be incorporated into a new information system. Now, there's another danger with this approach, designing an experimental system and say, oh, we'll give it a try, and then see if it works, okay? There are certain types of problems. This is very technical. It's mathematical. There are certain types of problems where if your problem size is small, it is doable. But the amount of time or resources it takes to solve a bigger problem is not linear. In other words, if you double the size of the problem, you might need 4 times the resources, the square of the increase of the size of the problem. Okay, I can give you one example. Let's think about UPS or FedEx. Okay, carriers. So they want to deliver stuff to different stops and stuff like that, and they want to optimize the path, right? To save fuel, to save time, to save insurance, and all kinds of other stuff. So I can develop a program, called it's an optimizer. The problem itself is called the traveler salesman problem. Okay, I can design a system, a very small program that will work very well when you only have to deal with like 5 or 6 stops. Okay. How many stops do you think a UPS truck has to make, on a daily basis? I don't think it's thousands.
A lot.
I'm thinking, more than 20. Yeah, more than 20, especially for home delivery. That's definitely more than 20. I would imagine it's probably in the order of maybe 50 to 70-ish. Would that sound kind of reasonable? Let's say it's 50. Okay. When the problem scales up from 6 to 50, the amount of time to solve the problem can become what we call intractable, which means the problem can still be solved, but not within the time frame when the solution is still useful. Okay? So that makes this particular approach kind of dangerous, because it is possible and very likely that you can develop a prototype of an information system that is efficient, capable, and and high performance when you're dealing with a small test problem. But when you try to deploy it to an actual large-scale deployment, it stops working altogether. I have seen many of those cases already. Okay, so this approach has that one factor that makes it kind of questionable. You really need someone who understands scalability, which means okay, here's a toy problem, and here's a test system to deal with the toy problem. It solved the toy problem without any problems. How well can it scale up is the big question. Okay. What does the project team do with the system requirements? Well, first you have to document it, right? So after project team studies the current system and then determine what the new system should do, system requirements are incorporated into a document. Remember documentation called System Requirements Report that describes the objectives for an information system. It becomes the test, okay, along different points of the implementation of double checking and see if the information system is moving in the right correction. Because this is not technical. A lot of times the system requirements report is not quote unquote technical. It just basically states what is required of the new information system. It doesn't say how to get it. It doesn't say exactly the numbers, but it just says okay, it has to fulfill these requirements. We have a figure here, probably over here, outlines the content of a system requirements report, which includes narrative descriptions and diagrams. So it's not technical, not a lot of numbers, showing the new system's user data, processes, objects, and reports. That's already kind of more detailed. There's a lot more detail than just the requirements. When management approves the report, the project can move on to the design phase. This is why the requirements cannot be very technical. Why? Which part of this paragraph do you think is the reason why the requirements cannot be very technical? In terms, exactly. Management people do not understand gigahertz processors or gigabytes of RAM and stuff like that. And besides, who cares about that stuff when your bottom line is, can we process 20,000 transactions per second? Now that is what management wants to know, okay? Because they can project, okay, and say that today we need to process 20,000 transactions per second, let's say per second. And according to our projection, because you can use the past to project the future. They can say within 5 years, we know that our requirement will bump up to 40,000 transactions per second. But we don't want a new information system in 5 years. So can the new information system handle, let's say, give it a little bit of padding room, 50,000 transactions per second? Now, management can understand the term, but management probably doesn't care how it is done. Okay? Oh, we can do it using a Oracle database cluster and using this kind of mass storage device and using SAN as the connection between the virtual machines and the storage and stuff like that. They don't care. Okay? They don't care how it's done. They don't care about the bandwidth of your storage area network. They don't care about the how many cores per processor. They only care about the bottom line. And that's what the requirement report is going to say. It's just the bottom line from management's perspective. Does that make sense? Okay. The details they will come later. Documentation tools. We kind of briefly talked about this already. We use Gaver, as a tool to do this. All right. We still have time. This kind of picture is called a DFD. Now, I really don't like these, abbreviations. A data flow diagram is fine. Okay, it's not really that much typing. I think the abbreviations came from people who just, use a lot of texting, so they don't have to type up the entire thing. But data flow diagram, basically shows, how information flows. You can see, from the previous page, it has a key. Everything that's a square is an external agent to the system. Everything that is kind of like a rounded edge, rectangle, is a process, a task, a process. Something comes in and something comes out. And everything that looks like this is a sink. I would refer to as a sink, which is also a source, It's stored data. Okay, it's stored in the system. It's typically corresponding to a database in this case, a table in the database. So in this case, we have a e-surfaces. It's basically a data flow diagram of e-surfaces. So we have students here. So student would generate a workshop request, and then the process is to enroll the student. And as the output of this process, this is the input, this is the workshop request. As the output, we have workshop enrollees. The workshop enrollees will be stored in a table in a database called workshop enrollment. And that table can be read by a produce workshop roster process, which is probably what the instructor needs from time to time. So that's how you read a data flow diagram. It basically allows you to outline, who would interact with the system, student, instructor, registrar, and also it will identify what kind of process that each person or each party will get involved in. The textbook, introduced the data flow diagram in the wrong order, because before this, they should have introduced what we have already introduced earlier, a use case diagram. A use case diagram is a lot simpler. It doesn't have any type of flow. All it is trying to do is to say, okay, there's an external agent which we call an actor in the UML called a student. So in this case, student is not a single student. It's a category of users. All students belong to this category. Students have two use cases of the system. In other words, they can use the system to serve two different purposes. One purpose is to enroll in a workshop, and the second purpose is to drop a workshop. They use the system for these two functions. And that's what a use case diagram is. And that's why I think they should have introduced the use case diagram first, because the use case diagram is good. It's a summary. It looks at the broad picture and say, okay, we have all these different agents, different categories of people and other systems that can interact with the information system that we are designing, and they can utilize the information system in these different ways. So there are these two diagrams, and the next one is kind of interesting too. And when people look at these things, they go, well, there are all these different diagrams. What do they do? How are they related? What is a sequence diagram? A sequence diagram is nothing more than, if you will, a script. Okay, a script of a play, a script of a drama, kind of like movie. Okay, what it is this is not describing a general scenario. This is describing a specific scenario. So in this case, a very specific scenario is a student will send a workshop inquiry to the workshop, so you can see the information going this way, and the workshop will respond by listing the open sections. The student, after reading the open sections, will select a section. Okay? Then that will go to the workshop and add the student to a particular section. And after this operation is successful, you will report back to the workshop that this student is enrolled in that particular section, and then the workshop can also report back to the student as if the student is enrolled in this workshop. So it's a particular use of the system recorded in a timeline. It is still a timeline. Time is flowing from top to top. Okay? And then you have all these different components that can interact, and you can see the interaction of these. It's basically a reminder of how the system can be used. But it's a very specific instance of using the system, because it doesn't tell you what happens when there are no available space in the section. See right here, when it says add student, it doesn't even say whether it checks whether the section still has available room or not. Okay, so this is making the assumption that the section does have enough room and the student can be enrolled. Okay. Are there any questions about a sequence diagram? Okay. Any questions? Are diagramming tools computerized? What do you think? Yeah, of course they are. If they're not, you can at least use use your webcam or your camera on the phone to take a snapshot of the picture that you draw on a napkin. then it's computerized, right? They have computer case tools. CASE stands for Computer Aided Software Engineering Tool. Another acronym. This one is an acronym because CASE, you can actually just say CASE. Commercial case tools such as Visual Analyst and open source tools such as Fargo Uml, and also the one that I showed you the other day. What is the name of that? I cannot. It doesn't have a interface from the front end, so I'll just type it up. I think it's called Gaver. This one is very simple, but as a result, it's also easy to use. Fargo UML is a little bit more difficult to use, because it does give you a lot of tools, but as a result of that, it's also a lot more difficult to use. Some of these tools are kind of cool because if you specify the activity diagram and also the state diagrams, it can generate programs. So it's kind of like a graphical programming kind of thing, except unlike Scratch, Scratch is pretty close to programming already because you are specifying loops, conditional statements, using variables and stuff like that. So you're pretty much programming already, except you're programming in diagrams. In a tool like this, it is possible to create activity diagrams, which we haven't talked about, activity diagrams and also state diagrams. We can specify enough details in the diagram for a case tool. This one is not one, but Fargo UML is a tool like that. It can actually generate Java programs to implement what you document in the UML diagrams. So that's kind of handy. At the same time, it also has one downfall. What if the generated program has a problem? Okay. That's one problem. The second problem is a generated program from a tool like this tend to be not very efficient because it's not hand-coded, it's generated by a computer. So it can be done, sometimes it's even correct, but in terms of efficiency, most of the time it is not as efficient as any hand-coded programs. We are running out of time, so I will stop right here. Remember, there's still a homework that you have to do, so remember to do the homework. And then we'll pick up from here next time.